Again, welcome everyone to another educational meeting by SimCap Louisiana. My name is Chris Melson. I'm the interim chair of SimCap Louisiana. We do have a great set of presentations for this meeting. But first, before the presentations, I'll give a few updates on the activities by ITE SimCap subcommittee or the ITE SimCap users group, and also some activities by the SimSub, which is a TRB joint subcommittee on simulation, in which I'm the co-chair. Then we'll have our presentations. The first presentation will be by Mr. David Hale, and it's really a continuation of the great presentation that Mark Yedlin did at our last meeting, where he discussed really the start of some of the traffic simulation from the 1970s through the 1980s. Here we're picking it up, looking at the major advancements in the 1990s. And I hope to continue that really into the present. So hopefully next meeting we'll have the 2000s. And then after that, we'll have a presentation by Tom Creasey from Caliper Corporation about the integration of highway safety manual methods into TransModeler. And then we'll have plenty of time, I think, for open discussion. So the first set of updates, again, is from ITE SimCap Committee. They did host a webinar in May. It was over I did attend the webinar, and I think the technical content was very well done and very informative. And it was over 3 case studies, practitioner case studies, really talked about model development and calibration, really went into detail on that. We do have an upcoming session that SimCap is sponsoring at the 2021 ITE annual meeting, which is virtual. It's going to be the SimCap session is going to be July 28th from 12:30 to 2. You do have to register for the annual meeting to attend this meeting, and we'll have 3 presentations. It's called the Traffic Analysis Modeling Simulation Cornucopia. That's kind of the title of the session. Three presentations, one about microsimulation, calibrating microsimulation models with trajectory level data. Another one is using big data for calibration, and also some interesting things they had to do for lack of data during COVID-19. And then also I'll be presenting at that as well about hopefully if I have time, what I'll be presenting today, which is the core competencies of a traffic analysis modeling and simulation practitioner. And then also as part of the 2021 ITE annual meeting, there's also the regular SimCap meeting, which will be jointly sponsored again jointly hosted with SimSub. I'll talk a little bit more about the last meeting we had that was also a joint meeting. That you don't have to have registration for the annual meeting. It is free. Actually, I think Eric Trippi, I think, is here. He's the chair of SimCap. Before moving on, Eric, is there anything you wanted to add about any upcoming activities?
Hey, Chris. Thank you for bringing that up. Appreciate you pointing all these different things we're up to. I think really the most important was that upcoming meeting on August 4th that we have with SimSub. No registration needed. Anyone can attend. And, at that meeting, we'd like to talk more about how we want to advance SimCap and some of the more of the things we'd like to do and moving forward, and maybe some other webinars and presentations and research and papers and things that we can do. So but yeah, that's really it, Chris. I'll give you back your meeting, but I thank you for bringing up the upcoming session and then of course the upcoming meeting.
Moving on, some of the updates from SimSub. Again, I'm co-chair of SimSub along with John Shaw from Iowa State University. And we did host a summer meeting, and that was definitely a joint meeting with ITE SimCap. And that's how I want these moving forward, is having these quarterly meetings essentially jointly with ITE SimCap. And Eric's been very, very good and flexible with that. At that meeting, again, SimSub's still evolving from being established as a subcommittee, as a new subcommittee, different than they were in the past. So we did establish 3 task groups. One a user needs, another one resources, another one a liaison and outreach. And we did talk about initial activities from each of these task groups. For example, the user needs, we did talk about developing, disseminating an annual survey to identify the primary uses of traffic simulation, the applications being analyzed, and also, of course, identifying user needs, having that as an annual survey every year where you can track those things and how those things change. That's a potential activity of that task group, for example. The resources task group, we talked about kind of building off of the resources that are on the ITE SimCap website, having more resources and then organize more into specific technical areas. And also on that web, maybe I'll try to bring this up. I hope whenever you try to showcase a website, it never works when you're doing it live. But another part of that, the resources task group would be also maintaining this calendar. And I keep talking about this calendar, but that's something that we do plan on doing, is maintaining the SimCap calendar that is on the ITE SimCap website. So this calendar just, again, shows all the SimCap related activities, whether that be research, whether that be training, or that also be practitioner webinars. So that's another activity that that users group is going to do. And then another thing I did want to bring up is that we're trying to organize a webinar with NOCO, the National Operations Center of Excellence, in September. That's going to be jointly hosted by SimSub, ITE SimCap, and also by the AASHTO Committee on TSMO, essentially. And I did send out a call for speakers. Essentially, we're interested in highlighting the uses of traffic simulation in real-world TSMO deployments. So I did put kind of, we need some speakers out on the ITE community. So if anyone is interested in presenting, again, we're looking for, again, how traffic simulation was used to evaluate TSMO strategies that were deployed. We're kind of looking at more of the public agency perspective, but really happy to include anyone's perspectives, such as a consultant that was actually developing those models. And with that, I did reach out to both the division office and the DOTD if they had any updates here locally, and they didn't. But I might just ask again if there's any local folks out there, if you wanted to provide any updates. I know the Capital Region Planning Commission was developing a new model. I don't know if Pong Wu is in attendance or not, but I'm just going to stop here for a second to see if anyone else locally has any updates that they would like to share. Alrighty. So without further ado, I will introduce our first presenter, Mr. David Hale. David Hale is a project manager, a senior transportation project manager for Leidos. He currently works out of the Saxton Transportation Operations Lab at the Turner Fairbank Highway Research Center in Northern Virginia. He has 26 years of research and development experience in transportation operations with an emphasis on traffic analysis tools and traffic control strategies.
All right, perfect. Appreciate the intro. Good afternoon, everyone. This is David Hale with Leidos in McLean, Virginia. My presentation today touches on traffic simulation news and developments from the 1990s. So happens that during most of the 1990s, I was a 20-something-year-old graduate student of transportation engineering at the University of Florida in Gainesville. My graduate advisor was Professor Ken Courage. For those of you who aren't familiar with Ken, he was deeply involved in the research and development of traffic analysis tools, even though his formal education was actually in electrical engineering. So anyway, following in the footsteps of Professor Courage, I was essentially diving headfirst into the world of traffic analysis tools, which obviously included traffic simulation tools. But while working on my master's thesis with Professor Courage, one of my main motivations for hanging around to pursue a PhD was my part-time job at the McTrans Center under Bill Sampson, who some of you might know. So I might estimate that I was spending approximately 20 hours a week on academic work under Professor Courage, while at the same time, another 20 hours per week approximately on traffic software development, support, and training under Bill Sampson. So in the 1990s, you might say there were some nice synergies between my academic studies and my part-time job. So now we can go to slide number 2. Thanks, Chris. All right, slide number 2 touches on the competition that was taking place in the 1990s between the traffic software vendors. Now, in the early 90s, there were very few private sector companies devoted to traffic software. To my knowledge, there weren't any probe data vendors as yet, and high resolution traffic data was not a hot topic as it is today. In the early 90s, there were mostly just a handful of popular traffic analysis tools developed primarily at universities, some of which were partially funded by FHWA. McTrans was a nonprofit company, I believe it still is. To some extent, we were competing with PC Trans, which not everyone's heard of, which I believe at the time was located at the University of Kansas. And in my recollection, most practitioners considered microsimulation hard to use. NetSim and FreeSim were the most popular microsimulation tools in the early 90s. And even though FHWA conducted beta testing of CoreSim for several years in the mid-90s, they actually did not release the first version of CoreSim to the public until 1998. Offline signal timing tools such as Passer2 and Transit 7F were quite popular in the 90s, and they both used macroscopic forms of traffic simulation. The arterial analysis package, which integrated transit and passer in a user-friendly fashion, was also quite popular in the early 90s. And the MS-DOS user interface screen shown on this slide certainly brought back some memories for me when I first saw it developing this presentation material a couple of weeks ago. The highway capacity software, also known as the HCS, and the AAP both use this type of user interface and probably a few other tools as well. I found this particular screen grab on Google a few weeks ago, but I actually haven't seen a picture of this screen in at least a decade or two, so it was kind of cool to see it. At any rate, in the mid-90s, you had Trafficware who started selling Synchro, and that sort of kicked off the private sector involvement in developing and selling traffic analysis tools. And then you had European simulation tools such as Vissim and Paramix. They started to pick up a few users in the late 90s, but I believe most practitioners considered those tools fairly difficult to use at the time. And as a final note, I believe the public and private sector competition remained fairly strong. I'd say maybe from about 1995 to about 2005 for about 10 years or so, until approximately the mid-2000s. And then once you got to the mid-2000s, the private sector started to become more dominant, and FHWA started making a more concerted effort to stop competing against the private sector. So now we can go to slide number 3. All right, so the Highway Capacity Manual was quite a big deal in the 1990s. We started to see many research articles comparing HCM results to simulation results. And I recall it being a fairly big deal when the TRB Highway Capacity Committee updated its control delay equation based on research results involving thousands of NetSim simulation runs. And this was a big deal because the control delay equation was the primary determining factor for level of service, and level of service in turn was the primary determining factor for many of the important decisions made by agencies. Therefore, simulation and capacity analysis sort of had a mutual impact on each other, and the comparisons between the two helped to improve the robustness of performance measures and equations and modeling approaches in both forms of tools, and essentially served as sort of an early form of multi-resolution modeling. Researchers began to notice that they could use vehicle trajectories to compare the results of multiple simulation tools, and to compute performance measures according to the published HCM definitions. You had folks like Ken Courage and Rick Dowling helped to publish an interesting chapter in the Highway Capacity Manual to help analysts understand what was under the hood of the performance measures they were seeing from the software tools. And I believe these simulation versus capacity analysis comparisons, which you might call SimCap comparisons, which began in the 90s, motivated people like John Halkias, for example, to develop the FHWA traffic analysis toolbox in the early 2000s and then into the 2010s. And as many of you know, the traffic analysis toolbox became a source of information on things such as tool selection, performance measure calculation, traffic analysis case studies, microsimulation, dynamic traffic assignment, and so on. And so now let's move on to slide number 4. Here on slide number 4, I'd like to discuss a newsletter article that I published in 1997 with McTrans, while again was a graduate student in Florida. At the time, I was under the impression that this article might be helpful, but actually, I think it ended up having actually a greater impact than anyone would have expected. Back in the 90s, most people didn't understand the ramifications of a stochastic traffic simulation. I believe it was approximately the year 1995 when I attended a NetSim training course in South Florida with instructors such as Susan Walker and Ku Lee and Amar Kanan from Command Sciences. And recall that Susan was the lead instructor, and she showed the trainees how to change the random number seed. Most people have never heard of a random number seed. Then she showed how the results from the model would change after people changed the random number seed. And frankly, this caused grown adults and certified professional engineers who actually had decades of experience to sort of freak out a little bit. They were like, whoa, wait a minute. How can we even trust this model? Which model result is the correct result? And so I think what Susan Walker did was she advised everyone to perform multiple runs, for example, 10 runs or so, and to just take the average of those results. And so that seems sort of like sort of a scientific data-driven approach is how they sort of were trying to portray that. So I think the training course participants mostly got the point, but at the same time, I think everyone's faith in the model was sort of shaken because everyone was sort of accustomed to the highway capacity software and other deterministic tools that always would give one and only one true result. And so, but anyway, let me bring the conversation back to this newsletter article from 97. So in 96, I just started working on my PhD at Florida. And one of my first classes towards the PhD was called Digital Simulation Techniques. And even though this was actually an industrial engineering course instead of a civil engineering course, it was a perfect course for students like me who are interested in traffic simulation research. And in this course, industrial engineering professor Sherman Bai taught the class using a simulation programming language called Simon. And that's Simon with A-N, S-I-M-A-N, instead of Simon with an O. So the whole purpose of the Simon language was to design and develop various forms of simulation models for all industries, not just transportation. For example, one of our homework assignments may have been to simulate and optimize the queuing at checkout counters for a grocery store such as Publix. And so in this particular graduate school course, Dr. Bai also taught us some of the basic principles of stochastic simulation. And one of those basic principles involved confidence intervals and sample sizes. And so he taught us a simple technique for estimating the number of simulation runs that would allow us to achieve a desired confidence level such as 90% or 95%. You could actually specify that in the statistical equations. Desired confidence level that the true performance measure lies between an X value and a Y value. And so as I took that class, I thought to myself, wow, this is what NetSim users should be doing, even though at the training courses being given by folks like Susan Walker and by consultants in the government, they weren't discussing topics such as this. So I proactively sought out Bill Sampson's permission to publish this simple newsletter article called How Many NetSim Runs Are Enough? And I believe I was smart enough at the time to include an easy sample calculation that NetSim users could understand while simultaneously jerry-rigging the numbers and also the name of the performance measure to be one that NetSim users would actually recognize. And as it turns out, this modest-looking newsletter article ended up having quite the nice impact. First of all, somebody developed a software tool called AccuSim for the sole purpose of automating these calculations. And McTrans actually sold quite a few copies of AccuSim. Secondly, a few years later, FHWA released an add-on tool called the TSIS Output Processor so that all Corsim users could determine their simulation sample sizes in this manner if desired. Thirdly, according to Google Scholars, of all the papers and reports that I've ever published, this newsletter article probably has the most citations by far. And then finally, I suspect most of today's popular simulation tools can offer a calculations quite similar to this. So therefore, despite spending only a few weeks on it, and despite having only a sort of a minimal amount of peer review, this article might end up being one of my actually biggest professional contributions. All right, next slide. Slide number 5 out of 8 touches on the connections between traffic simulation and traffic signal timing optimization in the 1990s. Personal computers, as you can suspect, or as you may have experienced, were much slower back in the 1990s. So the software developers had to take some significant shortcuts in order to include simulation within the signal timing process if they so desired. The first bullet point here mentions a tool called Sig Cinema by KLD Associates. This tool could optimize the signal timings for one intersection at a time by performing dozens of NetSim runs with dozens of different signal timing plans. And then, as you can imagine, after the dozens or hundreds of runs were complete, you could naturally view the moving vehicle animation for whichever timing plan ended up being optimal. The second bullet mentions Passer by TTI. Passer 2 was far and away the most popular version of Passer, and the objective of Passer was always to maximize bandwidth on the major street. My instructors taught me that Passer used a macroscopic traffic flow simulation in order to optimize signal timings. But unlike Transit 7F, Passer did not apply a platoon dispersion model. So instead, the platoon would travel downstream almost like a frozen square or a cube. Passer 2 contained an interesting module called the Lee Art animation, which my instructors taught me that some aspects of the Lee Art animation were real and some aspects were fake. But it was simply intended to help users understand the quality of platoon progression from the optimized timing plan. But Passer 2 was never a micro simulation, so it never had any idea of vehicle positions or trajectories, but nonetheless, the developers of Passer made the Lee Art animation look similar to a micro simulation. The third bullet mentions Transit 7F by University of Florida. And in general, Transit was a more comprehensive and robust traffic flow model than Passer, but it was also probably harder to use than Passer. And then FHWA then helped to implement and fund the development of stepwise simulation within Transit 7F, which was released to the public also in 1998 at a very similar time frame to Corsim. Stepwise simulation made it possible to simulate Q spillback, Q spillover, and multiple time periods in the context of a single signal timing optimization experiment, but you could also do a pure simulation of existing conditions if needed. But I also believe it helped to serve as a blueprint for some of the modern day highway capacity manual analysis procedure that you might see in the chapters for urban street analysis and freeway facility analysis. So they use some of those quite similar technologies and formulas. The final bullet point here mentions Synchro by TrafficWare. Synchro was a bit more of a black box compared to Passer and Transit because they didn't want to fully publicize their internal algorithms and formulas. But it did use many of the computational models from Passer and Transit and also from the HCM. But again, the developers never fully documented their calculations. However, I think everyone agreed that the user-friendly animation of optimized timings within SimTraffic, which was a commercialized version of NetSim, was a big hit with the user community. Next slide, please. Now, link node diagram data entry was a real game changer in the late 90s. Excuse me. In the early 90s, you saw most traffic analysis tools had the MS-DOS style user interface screens that we saw a few minutes ago on slide number 2. But with the release of tools such as Synchro and iTraf, you could actually draw links and nodes wherever you wanted them on the map, and then you could actually right-click on those links and nodes to edit their properties. Not only that, but you could import a bitmap background prior to drawing your network to make the traffic network look extremely realistic. and I attended a course and training course where iTraf was demonstrated for the first time. The audience was literally gasping at how advanced and intuitive the data entry process looked. So for professional engineers accustomed to the traditional traffic analysis tools and their MS-DOS screens, it was almost like a two-dimensional flatlander being yanked out of their two-dimensional world and being exposed to the three-dimensional world for the first time. So in summary, the link node diagram data entry was a total game changer, and one that, in my opinion, probably allowed the popularity and the practicality of traffic simulation to increase exponentially. Next slide. Now, I only got 2 slides left, including this one. In the 1990s, my understanding is that few, if any, of the professional engineers and state agencies even had access to a truly dynamic traffic assignment tool. Instead, traffic assignment was always a static analytical process that was mostly disconnected from traffic simulation. However, you did have academic researchers noting that static assignment was an oversimplified process, which in many cases would lead to unrealistic outcomes. And many people credit Professor Hani Mamasani with developing and publicizing the possible connection between traffic simulation and traffic assignment, which could help to make traffic assignment more dynamic in nature. I believe Dr. Mamasani favored mesoscopic simulation as having the best blend or compromise of computational fidelity versus computational efficiency for analyzing large networks. And I believe it was in the late 1990s that FHWA started to provide partial funding for DTA research and development, and specifically for Mamasani's Dynasmart P platform. However, FHWA would ultimately not release Dynasmart P to the public until the early 2000s. While at McTrans, we had a contract for a few years to perform beta testing of Dynasmart P and then report the testing results back to FHWA. And while conducting those beta tests, I remember being intrigued by the moving vehicle animation that it had and how different it was from the Corsim animation that I was accustomed to. Specifically, there were no individual lanes and no lane changing, as you might expect from a mesoscopic model. Instead, there was only a simple link node diagram with these large green dots sort of moving back and forth between the different nodes on the link node diagram. And the simulation step size was 6 seconds instead of 1 second. Or obviously today's microsimulation tools, they go down to 1/10 of a second and whatnot, maybe even finer than that. But the mesoscopic Dynasmart P resolution was 6 seconds. So what it meant was that every time the green dots moved, that represented 6 seconds of clock time. So that was a very different sort of concept. In addition, if the roadway had 3 lanes running in one direction, each moving dot actually represented 3 vehicles moving in one direction instead of just 1 vehicle, as we were used to seeing in Netzem and Friesen. At any rate, due to the favorable reviews of Dynasmart P by the sort of the traffic simulation community, it wasn't long before additional professors developed related tools such as DTA Lite and Dynasty, and it wouldn't be long before the private sector vendors would begin marketing their own DTA tools. And now we can move to the final slide, number 8. And on this slide, number 8, which is the last slide I have today, I'd like to discuss a fascinating topic, or at least I believe it's fascinating, which is microsimulation for a wide regional area. There's a lot of issues there. Conventional wisdom would tell us that analysts should use macroscopic models for wide regional areas, mesoscopic models for medium-sized sub-regional areas, and then microsimulation for relatively localized facilities and corridors. However, back in the 1990s, there was a big push to develop and publicize a powerful simulation tool called TransSims. TransSims could potentially be one tool to rule them all because it could do microsimulation, it could do DTA, it could do agent-based modeling, and it could do wide area modeling. But perhaps it was due to this complexity and comprehensiveness that the tool never became practical enough to be adopted by typical agencies for typical analyses. Nonetheless, there are still some top researchers and developers who feel strongly that in the future, the vast majority of all analyses should be in microsimulation alone, even for large regions. And the notion actually makes sense for multiple reasons. Firstly, computers are going to continue to become faster and more powerful, and it's going to continue to make microsimulation more efficient and easier to use. Secondly, if everything could be done in microsimulation, there would no longer be a need for messy data transfers that often cause data loss or data corruption. And third, microsimulation is simply the most robust form of modeling you can have, especially when combined with something like an agent-based modeling. But on the other side of the coin, you have a lot of other top experts who are advocating for multi-resolution modeling, or MRM, which would continue to involve extensive use of macroscopic modeling and mesoscopic DTA. In fact, some of you are probably familiar with the ongoing FHWA project on multi-resolution modeling, which is going to encourage modelers to simultaneously apply all three levels of analysis instead of just micro by itself. So what I'm trying to say on this slide is that even though TransSims itself may not have become an extremely popular tool, it did set the stage for a critical topic for us here in the year 2021, namely, which form of modeling should we be investing our time and energy in? Should we be pursuing research and development in microsimulation of large regions, or should we be investing in MRM and multi-resolution modeling? Or a third option could be perhaps a compromise, such as the hybrid simulations, which is sort of between the polar extremes, because in a hybrid simulation, you can sort of have the most important parts of the region simulated in microsimulation, while simultaneously the less important areas of the network are using perhaps a mesoscopic simulation. But in the FHWA MRM project, we heard that at least one major state agency has high hopes for hybrid simulation as being their maybe desired compromise between MRM and microsimulation. So in my view, this competition between the different analysis types and levels, the MRM, the wide area microsimulation, and the hybrid simulation is potentially just getting started. And some of the expert modelers in this audience might have a surprisingly strong influence on which direction that competition goes in. But as a final note, just remember, we wouldn't be where we are today if it weren't for the glorious 1990s. Thanks a lot.
Yeah, that's great, David. Thank you so much for your presentation. So yeah, I'm definitely going to open up for questions or also commentary.
David, this is Mark Yedlin. Great presentation. Thank you very much for doing that. And I also want to thank you for mentioning SIG Cinema. It was a product that I was involved with for 20 years. And
Did I explain it correctly?
No, well, I just wanted to add one point to clarify what you said about it, in that the tool did optimize signals, but it did not use NetSim for that purpose, not for the signal optimization. It used the capacity methodology only. It was based on how Sidra did it in that time.
Okay.
And you did a great job in mentioning the concerns that the profession had at the time of how do you deal with the stochastic elements of NetSim versus the deterministic elements of the traditional other techniques, including the capacity methodology. So what NetSim did in SIG Cinema was specifically provide statistics that the capacity methodology could not do. In those days, there was nothing in the capacity manual that dealt with overflowing queues or queue lengths. That was something NetSim was good at. So besides providing the animation, NetSim was used in SIG Cinema to indicate what percentage of a peak period you'd have a turn bay overflowing. We thought that would be a useful piece of information because we were very careful not to stick into those muddy waters of between deterministic and stochastic. And we didn't want to conflict with the capacity manual. And thanks again, great job.
All right, yeah,
hey,
thanks.
This
go ahead, Tom.
Creasey. Yeah, without this sounding like a software advertisement, I just wanted to say that regarding the topic of regional micro simulation, that tool does exist. At least one exists right now and has been done, a regional micro simulation employing dynamic traffic assignment. We've done that with our TransModeler software, but that does exist now. And maybe Chris, that's a future demonstration topic.
Yeah, absolutely. So there's you know, some really strong R&D going in multiple directions, and so people have got some great options to choose from. So I think it'll be real interesting to see what happens over the next 10 years and what becomes dominant, or if they become sort of equal options. But it's great that you know, some companies are really putting some serious intensive development into that option. I think the user community can only benefit from having that kind of an option.
There is one question we had in the chat, and I think it involves this figure, David.
Okay,
And
yeah.
just kind of where you got that figure. I guess it's from Corsim. Is from.
Yeah, this particular screenshot is an early version of TraFed. It might have been TraFed, you know, 5.0 or 5.1. I was really looking for iTraf. I just could not find, you know, I found a screenshot of, you know, the AAP, which I was very happy to find. But, you know, iTraf was around quite a bit in the early 90s. I'm sorry, the late 90s and the early 2000s. And quite a few people were trying it out. But it no longer seems to be easy to find, you know, on Google. And so I'm afraid it might be difficult to even locate. But that was the very first exposure that a lot of people had to this whole concept. And this screenshot here isn't even ideal for sort of illustrating, you know, the fact that you could put an aerial bitmap background in the back. And this actually is a bitmap background where somebody just typed in, you know, Corsim City and changed the colors a little bit. But a better example is, you know, an actual scene of, you know, having trees and buildings and roadways, and you're actually able to draw your network on top of that. That was just a huge, you know, game-changing development, you know, in the mid to late 90s, and it just took off from there. And so this is sort of the only example I could find on short notice, but you know, iTraf was the first time I saw it, with the people gasping in the audience in the mid 90s by, oh, you can actually do that, and then you can run a simulation after doing that. It was just completely different from what anyone was used to. But yeah, this is TraFed, but TraFed didn't come until a few years later after tools like Synchro and iTraf.
So we'll move to our second presentation. And again, that's by Tom Creasey. Tom Creasey is the Vice President for Transportation Engineering at Caliper Corporation. Tom's 39-year career includes 30 years in the consulting industry, most recently as part of Stantec's PD&E Group, and 7 years in transportation research at the University of Kentucky and the Texas A&M Transportation Institute. Tom is also the current chair of the TRB Highway Capacity and Quality of Service Committee, which oversees the Highway Capacity Manual.
Well, thank you, Chris. Hopefully everybody can hear me okay. But saw some familiar names. A few maybe that have known me for quite some time, but maybe you didn't know that originally in my career, my interest was in safety before operations. And so I had an advisor, a mentor who was a safety expert, and he used to tell me, you can't predict accidents. Back then we called them accidents and not crashes. And this was back around the late 70s, early 1980s. He said, no, there are too many variables. We're dealing with human beings here. You can't predict accidents. And so lo and behold, 30 years later, we have the Highway Safety Manual published in 2010 that, well, we can indeed predict a number of crashes. And in fact, all of Part C of the HSM is dedicated to these predictive methods. It was originally published in 2010 and 2014. There was a supplement that came out that included some additional predictive methods, particularly for freeways, which is in Chapter 18, and ramps, which is in Chapter 19. These prediction methods all have the same basic structure, and that is a base number of crashes, annual crashes, is predicted as a result of a safety performance function. And then this base number is adjusted by crash modification factors, which account for things like road width, presence or absence of a barrier, a number of different factors. And then also there's a calibration factor. You may think of it maybe as a fudge factor. And if the numbers don't quite agree with maybe data that you have, agencies can have their own calibration factors. So that's the basic form of it. These safety performance functions are typically regression equations based on data. And if you read through the HSM or even the research supporting that, you'll find a ton of these safety performance functions, but they're typically regression equations that estimate the average crash frequency for specific site types. So the methodology is basically that. It applies a safety performance function, then applies crash modification factors and calibration factors to predict this annual number of crashes. Then there's one more step, and that is, do you have historical crash data available? If the answer to that question is no, then the result is just what they call it, predicted average annual crashes. If there are crash data available, then it takes it to another step and applies an empirical Bayes analysis, which is really a fancy way of saying a weighted average between the prediction that's made as a result of the safety performance function and the crash data to give you this estimated annual crashes. So basically what that means is you can refine your prediction if you have historical crash data to go into it. So after the HSM was published, as you would expect, there were a few software tools that began to show up. IHSDM, McTrans's highway safety software, and some customized spreadsheets. So maybe some of you have had some experience with the interactive highway safety design model, or IHSDM. If you have, you know that it was written in some very late 1990s looking Java code using this grid or tabular format, and included wonderful things like horizontal and vertical stationing for your roadway project. So you have to go to your design plans and actually get this centerline stationing. Not terribly user-friendly, but functional. As you would expect for something like that, the graphics were also equally unimpressive. As you can see in this little picture here, the results are in an HTML type of table that you then had to, you could use it as it was, but if you wanted to do anything else with it, you had to copy and paste it into a spreadsheet. So again, functional, not terribly attractive or pleasing to the eye, but certainly it worked. There's improvement to that through the highway safety software, which is Trans is bundled with HCS. But again, it's the same type of this tabular format. The results certainly look better in the report, but again, some of the same constraints as if you used HSDM. And then AASHTO that had produced the HSDM also produced some spreadsheets. In some states like Ohio, took those spreadsheets and went to great lengths to customize those, and could do some other things like making some nice looking bar charts, stacked bar charts, and other things to go with that. But I think we've all had experience with spreadsheets to the point that, you know, they have lots of links in there and therefore opportunities for something to get broken and go wrong. So there's always the danger of that happening in using that type of tool. So Ohio is one of the states that has committed to using our TransModeler simulation software and said, can you actually can you add this HSM methods to your simulation software? And we said, we'll go talk about it and we'll get back with you. And so and part of our discussion was, well, we've never really done this before. In fact, we don't know of anybody that's added safety prediction methods to simulation software. Then the question is, within our software, what do we use and what do we not use? How much of the input should be auto-identified after the network is created, and what should we leave for the users to input? What should that user interface look like? How do we make it transparent enough so that agencies can customize it through things like calibration factors, severity distributions, or even maybe adding their own crash modification factors? On the plus side of it, we definitely saw benefits of having one tool used for multiple purposes. So not only could you do simulation as part of project development, but also then use it for safety analysis. TransModeler is a GIS. So being able to take advantage of the GIS functionality that's built into the software already, particularly the roadway geometry in creating your network, but also because it's a GIS of taking advantage of other spatially referenced data that just about every state agency maintains now, things like where your guardrails are located, things like pavement surface type, road width, whatever. And then in doing, typically as part of project development, we're really doing alternatives analysis. So being able to transfer the data for one type of analysis or evaluating one alternative to the analysis of another one. As far as creating it, and here you see basically just a section of our model network superimposed on just a Google map. Anywhere you have a network connection within TransModeler, you have a choice among several background maps. But it simply begins by locating the beginning and the ending point, just selecting the beginning and the ending point of your section to be analyzed, and then from there putting it into a tabular form, and that's what you see here. So once the site has been selected, then it divides it up. This is a freeway segment, so dividing it up between basic segments and speed change lanes. And then every one of these pieces is a row in the table, if you will. We've shown it by the study direction and the solid line and the opposing direction for that piece or segment using the dashed line. And then as I talked about the importance of the user interface, so simply creating a number of tabs for these different areas of data entry, such as crash data, traffic data, alignment data longitudinally along the section or cross-section data, things like lane width and median width, presence or absence of a median barrier. For our ramp method, it will automatically calculate the radius of a curve instead of having to get some design plans and look up what that is. It'll automatically do that for you and then provide that as an input to your analysis. And then I talked about agencies having other data available like guardrails or New Jersey barriers. Just to be able to, right now we just have it set up to use it as a reference point. So we're in a GIS environment, so just bring that in as a GIS layer that you can have access to as far as creating your data set. But you can see in the table across the bottom that we've maintained that tabular format where each row in the table is a study segment. And then as you go across the row, you just populate it with different data elements. So essentially how we've set it up to work is, again, utilizing the GIS functionality that's built in as part of the software and automatically identifying and segmenting these study sections, whether it's a freeway study section or a ramp, and then allowing the user to input the other variables through the GUI, performing the computations and then reporting the results. So if you listed the steps and the methodology that are in the HSM, essentially the first half of the process is setting up your study site and entering the data, or allowing the software to enter some of the data for you, and then stepping through the methods and the steps 7 through 11. In the end, it produces a report for each of these segments and for the number of years desired, the number of crashes, including fatal crashes, and then injury A, B, and C, and then property damage only. Also does the economic analysis for you based on some values, default values that you enter as part of the project information section. So it produces this in a table that you can use as is, or you can copy and paste it into a spreadsheet for something else. We have left it transparent for certain agency customization functions as part of our parameters. TransModeler is very easy to find out where any number of modeling parameters are. You don't have to crack open code to do it. It's from a drop-down menu. We can simply, and some of these are factors that agencies can simply go in and override if they have something that they want to use, things like these calibration factors that I talked about earlier. Currently, we're still in a testing mode on this, even though it is in the software, but there's a special key that you have to turn it on. We've done this for the freeways, which is chapter 18, and for ramps, which is chapter 19, which includes the ramp terminal intersections. So it's being beta tested by the Ohio DOT who we did the work for. We've also, for other people that might be interested in this, again, it's a safety analysis where you already have some data to use. We'd certainly be interested in, if you want to be a volunteer for this and getting some additional feedback. Since I've been in the software business for about 3 years now, I've learned really the importance of beta testing, and you just can't test enough. So we're certainly open if anybody else wants to maybe volunteer for that. We can get you set up. This is my contact information, and I'll be happy to entertain any questions that you might have.
Hey, Chris and Tom, this is Dave Petrucci with Federal Highway. Hope all is well. Thanks, everyone, for a great meeting here today. I do have a couple quick questions, Tom, if you don't mind.
No, sure. Yeah, you and I have talked about this before, Dave. So
we have. Yeah, I'm just curious. You get longer highways, larger projects. You're going to have more and more homogeneous sections of highway. Could you talk a little bit more about how TransModeler would help kind of break those highways down into homogeneous parts so that they can gain access to the methods?
Well, I mean, you're going to have the first step is to code the network. So, and ideally you'd like to have it set up already, but it's really easy being in a GIS environment to bring in, maybe it's just a GIS line layer and create that into a TransModeler network. It's up to the analyst to identify how you want to segment it. But let's say that you've got a 20-mile section of freeway. The analyst can simply collect the beginning and the ending points to say, this is the section that I want to study. And maybe it breaks at a county line or something like that. But you as the user have the opportunity to click the starting and ending point. But within that then, so for the freeways, there are two basic pieces of it. The basic freeway segments, and then what the method calls, what the HSM calls speed change lanes, which is basically the tapers where your entry and exit ramps join with the freeway. So it will automatically segment those into pieces, but it's really up to the analyst to choose the starting and the ending point of the method. But there's no limitations as much as you want to code into the software.
Great, thank you. And one other quick question about schedule. You're beta testing right now. Do you have an idea when maybe this might be available for prime time and for your customers? And what about possibly other methods in the HSM? Is that something that you're also looking at?
Okay, two questions. The first question is, and since I've been in the software business, I've learned to say coming soon. So we plan by, in other words, it probably at some point, Dave, we're getting ready to roll out version 6.1 of TransModeler. And we're really waiting on feedback from Ohio DOT, who we did the work for. So I know that we have they have a big transportation conference in October. And one of the technical, it's kind of a state level TRV. And one of the technical sessions is on safety, and I'll be making the same presentation. Hopefully we've done everything we're supposed to do. We just like to get a little more testing, but it's really up to us, and we could flip the switch at any time. on that. So it's really kind of up to us. We'd like a little bit more feedback on it just to make sure that that the results are as expected. And then your second question is, they came to us and said, we'll pay you to do it. And so, so much of software R&D is, at our own expense that we don't have, I guess if someone else was really interested in a partnership to see more of it appear in the software, we'd certainly like to talk about it. But if it's just part of our normal software evolution R&D, I don't know when that would be. Certainly, I think there's an interest in urban streets and rural highways, adding those methods. I don't know if anybody has added safety functionality to simulation software. Other than I haven't heard anybody else doing it. So we're kind of happy to be in that role, but and we've learned a lot for sure. But I just don't have any kind of time frame for when we might be adding more. I think it just depends on what is the market, what are the customers asking.
And there are a few questions in the chat, Tom. Thoughts on multimodal bike ped transit safety and mobility results in TransModeler. So just kind of asking your thoughts on that multimodal safety mobility component in TransModeler.
Well, the mobility part is in there partially in the ability, and I'm sorry, I don't want this to be a software advertisement, but we do simulate bicycles and motorcycles. We're working on a pedestrian module right now. On the safety side of it, we don't have anything like that built in. Again, it goes back to what is the interest of the market, of your users. Not saying that it's not important, but right now, we don't have any of that on the safety side beyond the freeways and ramps.
So for this beta version you were showing, Tom, is the segmentation, we all know that AGSM segmentation for freeways can be quite complicated and different from what capacity users were used before. So for this beta version, is the segmentation already functioning based on a specific type of GIS format, or is this pre-done with Ohio DOT partnership and something they have segmented before that you're testing?
It's based on, I'm sorry, go ahead, Gustavo.
No, I had finished. Thank you.
It's based on how it's defined in the highway safety manual. And for the freeways, it's really two things. It's either the basic segment or it's a speed change lane. And again, that's your taper, where your entry and exit ramps join and depart from the roadway. And so I don't have it open in front of me. It's a specific number of feet upstream or downstream of the ramp gore. So it's really consistent with how it's defined in the HSM.
And I'm going to pose a question to the participants here. There's two things we can do. We can discuss a few more topics, or I also kind of wanted to present about some of the work I was doing on the core competencies, again, of a traffic analysis modeling simulation practitioner. That'll take about 15 minutes or so. That would basically end our time on that.
Hey, Chris, while other people are typing that in, I just wanted to make a quick comment that at the TRB traffic simulation mid-year committee meeting for ACP 80 on September 15th and 16th, I think there's going to be a presentation by the project team on the traffic analysis capability maturity framework, which I think overlaps with the topic that you were about to discuss, sort of the ways that agencies can sort of level up to the next level of traffic analysis competency and capability. So the FHWA project managers, James Collier, and the PIs, Mohammed Hadi. And so maybe at the ACPA meeting, we can have a little bit of, comparison of notes and so on.
Great. This is definitely a personal effort. So it's what you all are doing is definitely
okay.
better,
Sure.
has more, but it's something that I've been trying to gain steam on and get feedback on. So, but maybe it's helpful for what you all are doing, actually.
Yeah, ours is somewhat modeled after the TISMO capability maturity.
Okay.
And instead of having 6 dimensions, I think we've got sort of 8 traffic analysis dimensions they overlap a little bit with the TISMO dimensions, but they're a little bit different too. So we're trying to develop all sorts of, subdimensions and interview questions that agencies can take to sort of self-assess their level and recommend actions to get to the next level in all these different dimensions.
This is actually going to be my presentation at the ITE annual meeting at coming up in a couple of weeks. And this was an idea that I've had for a while. I think other fields have this, and it's really defining a national, again, as I mentioned before, a national set of core competencies focused on the traffic analysis, modeling, and simulation practitioner. And so why is that important to develop a national set of core competencies? There's several reasons. One, it can provide a foundational structure, essentially, which you can do a lot of things with. One, you can start tying resources to specific competencies, and then you can see if there is a gap, for example, in resources, or if there's a gap in training, for example. Of course, there's national guidance on developing simulation models. This one is from the FHWA TAT Volume 3, this little screenshot. There's also the Anticipated Transportation System Simulation Manual. But these go basically hand in hand, where these national guidances show you the processes and methods used to develop models for decision making. And the national, again, the core set of competencies is really what, competencies, knowledge, and skills are needed to actually successfully do those processes. So they do go hand in hand as well. Another potential benefit is to form, again, educational curriculum. Again, if you see, for example, again, a competency that would make sense, that would be informed by, civil engineering curriculum, but there is a gap, for example, in the current knowledge, maybe that's something, again, to think about and maybe add to the core curriculum. For some agency-specific use examples, for example, here in Louisiana, the Louisiana Department of Transportation and Development uses core competency models for several of their sections. For example, the highway safety section they use this model for, where they, again, identified core areas, and then they identified resources, again, to ensure that there was a competency, resources to inform that competency. And then also the training section is really the one that did these efforts. And so they were interested in what is available what's available training, again, that we needed for that competency. And again, if there is a gap, is there something that we needed to develop in-house for training, for example? For the DOTD, they also did this for the traffic engineering section as well. And again, it seemed to be quite successful. Again, makes agencies think about this in a different way. And for example, what David was saying is more of, again, as more of a capability of an agency, what is needed for that. And this is a little bit more specific on what is needed for an individual, for example. So there might be some, hopefully, synergy with what I'd be presenting there, and also what would be needed for an agency as well. So another idea is you develop a national set of core competencies. Agencies can also use that and modify them to their own needs when they're looking at their own workforce as well. So actually, David, I think there might be some overlap here potentially. But again, this was something that go ahead, David.
Oh yeah, I think you're right. Some of the recommended actions in the capability maturity framework are sort of directed at the agency staff for, upgrading their analysis capability. And, others are sort of high level organizational changes. And so I think, yeah, it looks like there will be some overlap at the individual level.
Yeah, awesome. And again, full disclosure, this is just something that I felt was important, that I've been thinking about for a couple of years. And so this is really from me as a way just to an initial effort for folks to provide feedback on. And that's kind of what I want to get out of today, hopefully, if we have some time. So I just keep that in mind. This wasn't a project from FHWA. It didn't go through 3 rounds of getting feedback on, stakeholder feedback on. But again, it's something I did want to develop, especially something at least to, again, some of the bones you can say to get some feedback on. So again, this is for the practitioner. I defined 5 core competency areas that are listed here. Data, and I'll get into each of these in more detail. That's related to obviously utilizing data in multiple data sources, including big data and other different kinds of data. Modeling best practices is mainly knowing the best practices that are out there and the major guidance documents that are out there. The principles of traffic engineering and other related principles. I have and related because there's also some, I put in some transportation planning aspects of it, also some economic analysis aspects to that. Again, traffic simulation is really underneath traffic flow theory. And of course, that's really all underneath traffic engineering. And then I have here the modeling software, obviously being very, very fluent and knowledgeable in the software that's actually being applied. And then also being familiar with the applications that are being modeled so that they can, again, accurately be modeled in the model that you're building. So those are the 5 competency areas. I'll get into each competency a little bit more in detail. So with data, I defined essentially 5 core competencies. The data requirements is just understanding the data requirements by the analysis type and also by the model type. And that's obviously a big one and very, very general. A lot of things go into that. Same thing with the data sources. This is just having knowledge of the varied sources of data for model development, their benefits, their limitations. So this could include the traffic counts, traffic signal data, the geometric data. And it also includes probe data, some of the new emerging data sets, trajectory level data, CV data, for example. Again, these are general competencies that are actually fitting a lot in, including data analysis. This is a very general one that I have here that includes a lot of things. This ability to review input data for comprehensiveness, for accuracy, for reliability, the ability to work with big data, the ability to utilize multiple sources of data for model input, for example, data fusion and aggregation if needed. I did include GIS tools here. That's something that I saw on the DOTD competency models that I was looking at. And again, I think that is also a core competency, ability to utilize GIS software and tools to incorporate model input data. And then, of course, statistical analysis. Again, David was just mentioning about the number of random seeds, for example, number of runs you may need. So there's definitely a lot of statistical analysis that you need to understand and to also apply to the simulation results. And again, at any point, if anyone has any feedback on these, feel free to put it in the chat. I'm going to save the chat for my reference later on. There's also a survey that I'm going to have a link here at the end that I would also like your participation in. So again, this one is just knowing the best practices of oh, did I skip one? No, I apologize. So knowing, of course, the best practices that are out there. So the awareness of current best practices, as I mentioned, the knowledge of the processes specified in these major national traffic simulation guidance. I also put here internal processes. So that's knowledge of your specific state DOT guidance and their guidance documents, and also really even more localized things such as at your consulting firm, knowing their processes as well. I also put here, I didn't know really where to put this, but is also important, is the technical report and correspondence writing. It's really the ability to summarize the model results comprehensively, including the visualization options that you include. Also, yeah, just the general ability to convey technical information in the report and also to the roadway owner. That's something I debated whether to include or not and thought this was the best place to include. I won't go through, just for the sake of time, I won't go through all of these, but again, I did identify some major principles of traffic engineering that, again, it should be required as a core competency for, again, a traffic simulation modeling and analysis practitioner. Obviously, the knowledge of traffic flow theory, the ability to apply that to verify model output. I have here traffic engineering studies. That's the ability and knowledge to, if necessary, to gather additional data to actually conduct these types of studies. So volume studies, speed or delay studies. I mentioned here transportation planning, and that's really the awareness of the main principles of transportation planning, knowledge of models, but especially a deeper knowledge of the related model input data that you may use from these models in your simulation model. I did put here traffic signal operations, again, just so that they're, the practitioner is aware of traffic signal operation timing and the ability to accurately put it into the model. I also mentioned here geometric design, same thing, just to ensure that the geometrics are accurately represented in the model. Then I also included here driver behavior, since these fundamentally the traffic simulation models are built off of driver behavior theory. For example, this is the one that VSIM is built from. And so again, understanding that and being able to apply that to verify model output, if it's actually accurately being represented based off of this driver behavior theory and fundamentals. And then I have here economic evaluation for to apply that to the model results, like a benefit cost analysis. I have modeling software here. I didn't actually put any specific modeling software, so that's going to be dependent on again, the application, also the preference of the roadway owner. For example, in the traffic engineering section, part of the DOTD, they specify specific software, of course, that they have the practitioners use specifically. So again, this is something maybe that the agency specific person can use, from pulling from the core and then putting in their own specific software, for example. Lastly, these are the applications. Again, the idea I'm trying to portray here is that the modeler needs to have some foundational information about the application that is being modeled, whether that's ITS, whether that's, for example, emerging technology, and just to ensure that that's actually being somewhat accurately represented or somewhat reasonably recommended or reasonably represented in the model. And these are the main ones that I see. Again, this is about traffic. So they're, traffic operation strategies, ITS strategies, traffic management strategies, etc. So I wouldn't mind. I would definitely appreciate if this probably will take about 3 to 5 minutes. Essentially, I built a survey that just goes over the exact same thing that I presented and asks you to rate the importance of that core competency, including that core competency in, again, the national set. It's on a 5-point scale from no importance to high importance. Also, there's ability in that survey to modify these core competencies and to also, if you feel that something is missing. So I would just appreciate you all, if you could fill out that survey, I would appreciate that. Again, the idea is just, again, to present something to get feedback on.
Hey, Chris, it's Dave Petrucci. I do have a quick question. A long time ago, I remember in the Traffic Engineering Council at ITE, when SimCap was kind of just getting started, people talked about the idea of a certification related to analysis, maybe many other things, but SimCap-ish, there was talk of certification. Has that come up in the past few years, and is that something that is a conversation that should be had? I'm just curious.
Oh. No, yeah. Thanks for bringing that up. In terms of the SimCap, I think Eric Trippi already left, but in terms of the SimCap activities, that hasn't really been brought up, but that actually has been brought up in other venues. For example, Mohammed Hadi brought that up a couple of times, during his TRB activities and things like that. So I don't know if it's an initiative that people are pushing right now, but I don't think it's been forgotten and can definitely be revisited. I appreciate you all attending. I definitely appreciate both David Hale and Tom Creasey for their presentations.